So what is a function which its derivative is the same function? So that's the main goal of this video, and let's get on with the demonstration. First of all, some definitions. The first definition is, and the only, is f of x, its derivative, it's equal to f of x plus a small step in x, we call the x, right? Minus f of x divided by that step, dx. Okay, and we can call this also f of x, right? Because of this expression right here. So, and because dx is such a small step, it tends to 0. Okay, the smaller the better. So we can organize this even better, right? And what we get is the following expression: x plus dx, okay, equals to f of x plus f of x dx, right? And we can further simplify this, taking these two out, and we get f of x 1 plus dx, right? We just factored f of x out. Okay, so final expression, f of x plus dx is equals to fx 1 plus dx, and we are done. Okay, what happens if we evaluate this function, right, if x is equal to 0? So what we get is, this is small, f of dx is equals to f of 0 1 plus dx. Okay, so another evaluation at dx gives us what? Gives us like 2dx equals to f of dx times 1 plus dx. Because we already know what this is, right, because of what we found right here, we can further simplify this, and we get substituting for f of dx, that this is f of 0 1 plus dx times 1 plus dx. So it's basically just f of 0 1 plus dx squared. Okay, so we can even try a third evaluation, this time at 2dx, and what we get is f of 3 dx, right, is equal to what? Is equal to f, let's substitute here, 2dx 1 plus dx, right? Because if you take this x puts a 2dx here, we get 3dx, and here we get 2dx, all is correct. So we can further simplify this, because again we know what this is this, so we can say that f3dx is equal to f0 1 plus dx squared times 1 plus dx, and that's just really f of 0 1 plus dx cubed. Okay, and you're seeing here a pattern, I think, because I saw it, and that pattern is, if we take n dx steps, what we eventually get is f of 0 1 plus dx and power to n, I think, yeah, power to n, right? Because if we just take a look here, when we have 2 here and f of 0. When we had 3, we got 3 here and f of 0. So that's the rule that we found. Okay, so next what we can do is say, what is the value of n? What's the value that n needs to have such as n dx is equals to x, being x any number that I wish. So what we can do is just substitute. We make this definition our second definition, right? And we can just substitute and get f of x is equal to f of 0, right? And what we get here is we can say that dx is equals what? Equals x divided by n. And because dx is just a small number and x is a finite number and needs to approach infinity, right? Because if x is a finite number, only with n approaching infinity we get dx approaching 0, like we said before. So what we get is 1 plus dx is just x divided by n power to n, with n approaching infinity. Okay, so what we get here is f of x equals to the function evaluated f0 e power to x. And this is just because if we take a look here, this is the same as saying the limit of n approaching infinity of 1 plus x divided by n powered by n, and that's just ex. Okay, and this f of 0 is just the constant. It's just a constant because it's the function evaluated at 0, so it can be 1, 2, 3, 4, pi, I don't know, whatever. So we got to a nice conclusion. F of x just needs to be a constant times e of x.